Okay, velocity vectors.
Well, you've already done it all.
And applications. A person is walking. A person is walking. And their walk is defined as so. The vector R1, which is P plus T times D. And R1 is equal to xy negative 1, 2 plus t for negative 3, where t is measured in hours. So, what's their displacement? Okay. So displacement is S, which is equal to, we're using V, so velocity times time. Your displacement is your velocity times time, right?
Oh my god, why is it physics again?
No, it's physics still.
Oh, what? No, I'm done with physics.
What's your speed?
SPP.
SPP, what's your speed?
Oh.
What's speed?
4, negative 3.
Speed is equal to the magnitude of the velocity vector, right? We care about its size, don't care so much about its direction. And what is this magnitude for this?
5.
So it's 5, right? Well, it's root 25. Root 25, which is 5. And what is the speed likely measured in? Oh wait, I should say displacement in kilometers, let's say. In kilometers. So then the speed is in kilometers per hour. Okay? So if you have a velocity vector, you can work out the speed at which it's moving. You can work out the displacement, right, by multiplying by time to see how, how far it has gone. Let's say that, let's say that we go to a new page. Let's say that R2 is parallel to R1, and the speed is 35 kilometers per hour. And R2 passes through the point 911. 911. Yeah, that's odd.
Wow.
Half prime. Okay, it passes through the point 911. So, question is, how are we going to find that then? Magic. What magic are we going to use? Come on. R1, R2. R is what?
R2.
Oh wait, R2 is equal to.
Yeah. R2 is equal to?
Plus T.
What's your speed, man?
35. So
Okay. How does that compare to R1?
It has to be parallel. So
7 times faster, right? So 35 kilometers per hour divided by 5 kilometers per hour means we are going 7 times faster. So 7 times V is 7 times 4 negative 3, right? Which is the velocity, which gives us 28, negative 21. We could also say that 7v is 7 times 4i minus 3j, right, using components, which is equal to,
So we essentially just found the scalar multiple and just multiplied it.
yeah, we're doing a scalar multiple. We got to say how, we didn't have to, unfortunately, we did not have to get the unit vector, right, and then scale that up. Because we could simply say, hey, this is 7 times as big. Had this been, 40 kilometers an hour, something like that, that was also divisible by 5, that wouldn't be good. 37.5 kilometers an hour, it's something we may want it to go to a unit vector and then multiply that by the number, right? Okay, so that would have been possible, but not really, necessary, I guess, in this particular case. Okay, what's R2? Using column vectors, because they're much easier to work with.
9, 11.
9, 11.
Oh, plus T. And 28 over, yeah.
Okay? So that's how we get R2, right? We're given that it's parallel. Parallel means that it's going in the same direction, but it's moving at 35 kilometers an hour as opposed to 5 kilometers an hour, which means it's 7 times faster, so we have to scale it up by a factor of 7. So we take the velocity, right, which is simply the direction. I don't care where you started with R1, right? It's the velocity. It's how is it moving with respect to time. C. At what time is R1? Due north of the observation point, which is the origin. So you guys have done physics, right? You know about frames of reference and stuff?
Yeah.
Okay. So when are we due north of the origin, which means what? Where are we?
0 degrees.
We're looking for the
Y-intercept.
y-intercept, right? Looking for the y-intercept. So it means you're on the y-axis, right? That's when you're due north, okay? So y-intercept, that's going to be due north. Okay, so what are we looking for, right? We're looking for the point 0y. Okay, we're dealing with R1. What's R1?
4
Negative 1 plus 4t. And
2 plus, or 2 minus.
2 minus 3t, right? So what are we going to say?
Well, 5T.
0 is equal to negative 1 plus 4t. T is equal to 1 over 4. How long is that?
No, it's hours, so that would be 15 minutes.
15 minutes. So at what time? Well, 15 minutes after we started, I guess. Well, we gave a starting time, so. So at time 15 minutes, so 15 minutes, quarter of an hour. You could say 1/4 of an hour, I suppose, but yeah, really, let's just go to minutes. So 15 minutes. Takes 15 minutes to get from where you were to directly north of the observation point or the origin. Okay, questions? Concerns? Next. Last. Well, if I be lessons don't go that long, right? It's the other classes just grinding on with the lesson.
45 minutes? What?
No, we're not done yet. How far apart are they after 5 hours?
Oh, wait.
So it's all, well, it says we substituted in minutes. But yeah, is that actually how you do it? Substitute?
Yeah, I guess.
Well, what are you going to figure out?
Wait, how far apart?
You figure out the displacements, right? If you go, where are they? What's R1 equal to?
Oh,
Negative 1.
negative 1 to
Plus 40.
or plus
Sure. And?
Oh, 2 minus 3.
Okay, which is, for this particular case?
4, 5.
5.
And?
2 minus 3, 5.
Okay, which is?
19.
19.
Negative 12. No, 13. Negative 13.
19, negative 13. R2, on the other hand, is?
9.
9.
Oh, can't remember. Plus 2018.
Yeah, plus 28t. I'm saying minus. Are we on the same question?
11 minus 11, 21.
Okay. So R2 is? 1, 1.
What is R squared?
Yeah, what is the R squared? R2 is?
9 plus 28, 5 times 9.
And? So R2 is?
Plus 28 times
5, 149. 11 minus 105. I'm there. Are you there? Come on. Negative 94. God, you guys got to learn to do arithmetic. Okay.
R squared.
I'm sorry, we have to.
Oh, yeah.
Oh, I don't know why I do that.
Where you talked about radiuses last class.
Oh, yeah. I don't.
Whoa.
Airball.
Go into yourself. Can I say it? Can I say it?
As
He
if you
meant
meant
to
to
do
do
that.
that. Yeah, I know. Yeah. Plan that out the whole time. Okay, how far apart are these guys?
149 minus.
130.
that's-
130.
Yeah, it's a distance formula, right?
Yeah.
So,
130.
what's D equal to?
130. I've gone to practice. 153.
149 minus 19 plus?
You know what?
Just give me the final number. This is a calculator problem at this point.
153.
153.
Exactly. Yeah.
0.169. Okay.
That makes no
because-
sense.
153 kilometers. Distance being a scalar, you'll notice the D has no little arrow up top right. We're just interested in how far apart they are. Not the displacement from one to the other, which we could work out as well, right? But we don't need. Okay, good? Yeah, okay, do your questions.
Minus 13.